So welcome everyone. My name's Peter Hansons, one of the organizers of the Data Engineering Meetup. Still in the COVID era, so we're doing a live stream encompassing Brisbane, Sydney, and Melbourne meetups. It's my pleasure to welcome two awesome speakers today. We've got James Weakley, who's the CEO of a new data engineering startup here in Sydney, Newcastle, called Omnata. He's going to be taking us through operational data in the cloud, which is really cool. And we've also got Michelle Playfair. Michelle does heaps of really cool conferences with YAL conferences, and is generally just totally awesome in and around the tech community. But today she'll be taking us through what's coming up with YAL Data, which is a pretty awesome, totally amazing data engineering, or I guess more broadly data conference that encompasses also data science and machine learning and stuff like that. So it'll be really cool to see what's happening in that space and what to expect, I think, on a May timeline or something like that this year, Michelle. I'm going to subject you and put you all through a quick reInvent recap to make sure that you can drink the Kool-Aid too. Plenty of really exciting announcements that came out of reInvent in 2020, a month ago, especially for us data engineering folks. So lots of excitement there. So please do stick around. But without further ado, I will stop sharing my screen and let James take it away.
Cool, thanks, Peter. Let me share mine. How's that?
Yep, perfect.
Cool. So yes, thanks for having me, Peter. First event of the year, very exciting. And I'm speaking on a topic today. This will probably go for about 30 minutes, give or take, and hopefully have some time for questions at the end. On a topic that's very near and dear to me, operational analytics. But first, a little bit about me. Back in university, I studied computer science, went on to be a software engineer, a consultant, eventually an architect. I've always been really lucky, fortunate enough to work in very progressive work environments where as things like DevOps practices and eventually public cloud evolved, they were very high on the agenda. About 5 or 6 years ago, I started coming across situations where I was building software that happened to be processing large data sets. I remember in particular having to produce a sort of time-sensitive data extract over hundreds of millions of records. And that's what really got me into the Hadoop or Spark space, where you could use those building blocks rather than write something big entirely from scratch. And I've been in that space really ever since, focusing on cloud data warehousing and machine learning, as opposed to my background of traditional business systems. Big fan of open source. As an early Snowflake customer in Australia, I've authored a bunch of open source projects to help manage Snowflake, which are on the Snowflake Labs GitHub. I should admit up front that I haven't always been successful in this area of operational analytics, but I've always learned from my mistakes. In fact, I've built a software company around some of my lived experience in doing this. So as Peter mentioned, yes, I'm now a vendor. I will find a way to plug our product somewhere in this talk. But rest assured, the talk is much broader than the scope of Omnata. And I do want everyone to try and get something out of this talk. So I hope that by the end, regardless of your stack, you'll have an appreciation for some of the general challenges when taking analytics projects into production, and some ideas on how to overcome them, or at the very least, a list of things you should have considered. What is operational analytics? Good old Wikipedia definition is just that it's a subset of analytics that focuses on improving the operational nature of a business. I would say that that's now so common, it's probably what most people mean when they say analytics in business. I think it's really important in Australia because compared to the rest of the world, we don't build a lot of tech products here. Australian companies, from what I've seen, tend to apply technology to industry problems, like whether it's agriculture, geospatial, energy, resources. So we need to get really good at operational analytics because it's really becoming our bread and butter. I like this quote from Bain Consulting, so I thought I'd include it in full. One of the biggest sources that they see clients struggling with is the last mile. That is the gap between great analytic output and actual changed behavior. That creates value. So the reason I put the slide in here is just to warn you that statistically speaking, at least according to the big consulting shops, you are actually likely to encounter challenges that you didn't expect. And before I dive straight into the technical side, it would definitely be remiss of me not to remind us all that most projects fail or die, not because of technical challenges, but because of organizational ones. I don't think I've been part of any project where we decided, oh, look, can't fix this bug, can't overcome this technical challenge, let's wind it up. It's always more like, we're not sure we want to continue to resource this initiative, in light of other priorities, that sort of thing. So really, to lay the groundwork for success, starting with the business decision maker, is the opportunity well understood, and do your stakeholders agree that it's a problem worth solving and has significant enough benefit? Once you know that, you can have an idea of what your budget could be, and it might actually be more than just what's sitting in the technology budget already. I think too often technical people, and I'm probably in this category, sometimes evaluate opportunities like new products based solely on the costs they might feel is reasonable or that they already have access to, without considering the actual opportunity. And I think the same thing is true for resourcing. You can always extend your workforce temporarily with outside contractors. So if you know the actual size of the prize that you're looking at, you can actually broaden your options and have a better chance of succeeding. You should develop and nurture strong relationships with decision makers, and so they can stop perceiving you just as a cost center, and they might actually want to listen to you and back your suggestions. And you should also listen carefully to them as well. The more you understand the costs and the revenue model of your business, you'll develop better ideas that have more impact. Also, operations staff are really important. You need to get in the mental space of those people and test your assumptions with them. Don't just assume that you can change the system that they use and then everything else just takes care of itself. Part of this in analytics is, can the problem be economically solved? So being able to predict something doesn't always mean you can realistically do something about it. And operations staff will always tell you that if that's what they think. And finally, the operational system owners, I put this in there just in case they sit outside of where you are as a data engineer. As you plan out your data stack and how it fits in with everything else, don't assume that they're across what you're doing or that they automatically agree with the technical vision. So keep them looped in, and when the time comes to plug into their systems, you're not surprising them. With that said, moving on to the almost obligatory history lesson, not wanting to insult your intelligence, just to set the scene. This diagram is kind of a standard historical understanding of operational systems versus analytics. There's probably hundreds of diagrams like this on the internet, but the essence of it is that traditionally there's operational systems where business processes were implemented, usually associated with high volumes of transactions. And then there was analytics on the right side, where trends and patterns are discovered to inform leadership. I mean, this is very simplified because both sides now are often composed of lots of different parts, APIs and serverless and all the rest. But you get the idea of the historical delineation, hopefully. And the systems that back these evolved kind of separately according to their selective pressures. So, for example, operational outages are very expensive. So there was decades of big investment into areas like version control and automated testing. This grew to incorporate not just the applications themselves, but the infrastructure that they run on. Whereas in contrast, in the analytics world, the big problems were things like inaccuracies in data, disparate data, ability to consume the data. So the efforts there went instead into things like warehouse modeling, data quality, and business intelligence tools. So now that we want operational analytics, clearly there's likely to be a need for the right side to catch up to the left in some areas. If these systems are going to be trusted to have these important operational roles, there's really a bar that needs to be met. So where do we start? I could start with Matt Turk's diagram on all the ways we can solve our problems with, and Michelle's been blinded by it. We don't have time to go through those. So what I'm going to do instead is zoom in a little, and I'll submit to you
Just
my
one question. Do you have Omnata on that diagram yet?
No, I need to follow him up about that.
You totally do.
Yeah.
2021.
It's actually out of date, that diagram.
No, it's completely without Omnata,
certainly. So this is kind of my biased view of the modern data stack, but you could argue about the products I've chosen to put there. You know, we use Stitch, not Fivetran, or we use Power BI, not Looker. But if we got hung up on those things, we'd end up back on the previous slide. So, and I've left out a lot of other things, specialized tools for things like security and governance and all the rest. So, but this should act as a reasonable proxy, I hope, for what most people are doing. And just talking through the components kind of left to right, which is sort of roughly the direction that the data moves. We have data acquisition from source systems. I'm just going to assume an ELT pattern because that's kind of the norm now. So that's extract, load, transform, just landing the data quickly into a staging area of your warehouse. We have transformation and modeling of the data in the warehouse, which could include merging multiple sources, potentially external ones. And then on the right, we have everyone else lining up to feed off this data-centric architecture. I think for the other apps, whether it's internal or external, in a lot of situations, we no longer need enterprise middleware. We can just continue this data pipeline out to our other apps. So for various third-party apps, now there's general purpose tools like Census and HighTouch, which can push your data out from where you've modeled it in the warehouse out through their APIs. I would add that you should first consider carefully whether or not you actually need to move the data out of your warehouse anymore. If you're serving really high volume external traffic, there's probably good reasons to, but a lot of third-party apps, they may require the data locally, which is a consideration. But otherwise, those things aside, say particularly if you're a Snowflake user and you can dedicate this auto-scaling bandwidth now, just plug straight into it. You can use the client library for the language of your choice. We have data science and advanced analytics, where we look to make predictions off the events of the past. The way we operationalize these tends to fall into two categories. We've got real time, where we don't have the luxury of waiting for the data pipeline. This is usually for something like a new customer shows up at your website. What information do we want to show them? But for everything else, there's batch, and that could be micro batches in near real time if needed. I see those predictions coming off those batch scoring pipelines as a data asset that should be stored in the warehouse for reuse elsewhere, particularly pushing out to other apps. I think you really want to avoid having these really long machine learning pipelines that just serve one purpose. And last but by no means least, we have the traditional BI tool use cases. They are still as important as ever for guiding decision makers, but for mainly time reasons, I'm going to put them aside for this talk. There's usually limited downstream system use of that data. So over the decades, in the software delivery space, we've achieved a bunch of things. And I'm going to use this list and talk about how they might apply to this stack. So we moved away from creating backups of our code and embracing version control systems like Git. This is very foundational. It's not only an audit trail, but it's a method for collaboration, and it enables pretty much everything else we need on that list. So on the data replication side, these often aren't really subject to version control. For example, Fivetran has a point-and-click GUI to sort of streamline the setup. But at the same time, as a replication tool per data source, it doesn't really change very much once set up. So you could probably argue the risk is low. And there's other things like often you're using OAuth flows to connect to these systems, which are inherently interactive and tricky to version control. Snowpipe can be managed. That's the Snowflake data loader. Using snowchange, one of the open source projects I mentioned at the start. If you're using the platform as a service replication tools from your favorite public cloud provider, these will probably have some way of expressing their configuration as code, which I think is a really sensible idea. Inside the warehouse, transforming, I think, is where the big change risks are. And this is where DBT really shines. I think if you're wondering what all the fuss is about DBT, then you can start with this benefit. It's driven entirely off a code-based definition that sits in a version control system like Git. On the consumption side, talking about version control, I'll reiterate again to consider the need to copy data out of it as a first point. On the data science side, it's a bit tricky here. Notebooks are notoriously difficult to do good version control with. They're very popular with data scientists, but debate continues about whether or not you should try and put them into production. Netflix tend to advocate for running notebooks in production, but a lot of people disagree, especially architecture experts like ThoughtWorks strongly discourage it. So I'll come back to that point soon again. Managing change to machine learning APIs is definitely an emerging field. The versioning here is about both the actual endpoint deployment, but also the decision on whether to deploy a new version, because it's often made at the end of a training experiment, which makes it a little bit unique compared to deploying application code. SageMaker, though, is an example of a fairly mature set of APIs around deploying instances through client libraries. We moved away from manually testing our changes to using code to test our code, which is really important for agility, because as the system gets more and more complex, you don't have to slow down the pace of change. We also moved away from manual deployments to deployment tools that are fully automated. And as I mentioned, this is now not just the software itself, but the infrastructure as well. So now it's really common to deploy an entire application stack from a code branch. So applying this here on the data replication side, again, I would say there's a lower risk due to the low frequency of changes. As it lands in the warehouse, like any interface between systems, there is a contract, whether you recognize that or not, or whether you define it or not. So you do have to figure out how to uphold it, particularly if you're working across different teams. With DBT, you have data tests, because data downtime is a thing, as data quality issues in a pipeline are just as critical as logic errors in an app. They can cause the whole system to require shutting down. if the impact is bad enough. So when you're using DBT, ensure that the testing occurs in some kind of blue-green fashion so that you're detecting errors at the right time. There's a really good DBT community article on how to do this. Zero-copy clones in Snowflake are helpful when doing this. And this is also really where the ELT replication pattern is really useful, because being able to rebuild your data transformations from a raw staging area, if you do discover an issue or if you do need to roll back, is critically important. You can't be chasing that data upstream back to the systems that it came from. Aside from that, you do need to understand how each downstream system tolerates schema changes and the extent to which you can handle them gracefully. The way, this is another contract at this boundary. So how I've solved this in the past is to make it really clear that a particular DBT model is being consumed by an outside system. So you could write a data test that reflects the expectations of the consuming system, and that test essentially protects against breaking that contract. So it's being enforced within that DBT project. I've once even gone a step further in DBT and written a test that provides a performance assurance as well. So in this situation, a particular Tableau dashboard was always filtering on this one column. I created a DBT test which asserted that when you do filter on that column, that the clustering depth in Snowflake was low, so that not only did you have the schema contract enforced, but also a bit of a performance guarantee as well. So that's something to consider. Just going back to pick on notebooks again and change management, I've experimented with a few different options over the years. One big difference I'd call out is in the application world, because we're talking about business logic, they can exist separately to production in just about every way that matters. But with analytics systems, because their behavior is critically linked to production data, it's a lot more complex. You can't, for example, test a change to a machine learning model's hyperparameters without the data. So because until you observe the impact to the model's accuracy, you don't actually know whether or not you want to deploy it. One thing I tried as a Databricks customer was adding parameters to notebooks, which caused different database configurations to apply. So for example, you could have a notebook in dev mode, which couldn't write to production. And then only the service account that executed the notebook in production actually had permission to write back to the prod database. But still, it's really not ideal. These days, I tend to advocate for using notebooks for discovery and exploration, but for a critical machine learning pipeline to build it, in a robust manner. I'm also seeing a trend of machine learning features being moved into feature stores, and a bunch of investment going into feature store products like Tekton is a recent one. In an upcoming DBT office hours talk, I'm going to demo how to do this feature engineering in database using DBT. The reason I mention feature engineering is because the less steps involved during the machine learning training process, the less change you have to manage there. And then it becomes simpler to migrate it to something more robust. We have, through public cloud, high availability has entered the reach of just about every business, removing single points of failure, but also importantly, designing for failure and not letting failures propagate through your entire stack. So naturally, you need reliable data replication that can handle failures on either side gracefully. And they have to be designed to accommodate failure on either side. Again, this is another argument for the ELT pattern. You keep that replication layer nice and dumb. And you don't have to manage a lot of changes to it. All it does is move data as is. And I would really suggest don't build your own data replication tools unless you absolutely have to. There's so many good ones now that are out there on all different platforms. Data warehouses, in terms of resilient infrastructure, have come a really long way. All of the cloud ones have really good uptime and scalability. Snowflake is even multi-cloud, which not many other production systems at this point can claim. I think for all of these systems, it's also important to be able to detect and understand failure at the point where it occurs. So we used to call this monitoring, and now it gets this fancy title called observability. But what I'm saying is consider some kind of centralized logging mechanism that provides this for you. Security is everyone's concern, and unauthorized data access is a risk that you have to build into the way you deliver these platforms. I think it's worth pointing out sometimes in the old divided world that a lot of analytics teams probably considered security to be the responsibility of the IT team. But as we see these blended data and analytics and tech teams emerging, should make sure that that responsibility is understood. Every cloud system has a shared security model. You should really understand what parts fall to the vendor and what falls to you. I touched on this before around the differences between analytics systems and needing access to prod data. Analysts often have broad access to full data sets, along often with a means of extracting it en masse. And that's a risk that you have to manage as well. So there's no use building this really nice authentication and access control mechanism around your warehouse if people are routinely moving sensitive data in and out of it. Even if you turn a blind eye to it, it's probably still happening. I'll balance that by saying they do need access to that data to do their job. So a simple blanket rule that might work in the application world, like nobody gets access to the prod database, aren't actually practical. Instead, you have to put in the effort to instill a security culture, have the right controls, but also remove the temptation for people to want to move data outside of where it's protected. Now, understand the way they want to work and make sure that it's supported well. And there's cost savings of infrastructure being managed by the vendor from a security point of view that are worth making note of. If it's their job to track and patch vulnerabilities in the stack, then that's time back in your day, which is good. We want to consider the economics as well, because with unlimited resources, anything's possible, but we don't live in that reality. To borrow Werner Vogel's term for building software, which is stop doing undifferentiated heavy lifting. In other words, for the business that you are in, try and as much as possible outsource the common tasks and focus engineering effort on that which brings unique value to the business. On our stack, so this type of outsourcing as it applies to analytics means leaning on vendors for the mundane parts. Don't underestimate the cost of doing bespoke integration unnecessarily. Further to this, when you're comparing vendors, and this really applies to the entire stack, make sure you do a trial and factor in how much effort they've put into the developer experience, because a tool that costs, say, $100 a month but requires extra hours to configure and manage is probably more expensive than a $200 a month equivalent that doesn't. So just keep your eye on what you're spending your time doing and whether it's spent in the right areas. And as far as reliability of that infrastructure that you're outsourcing, your analytics pipeline is going to include a lot of SaaS and or PaaS parts. So it's really up to you to make sure that these vendors offer you the uptime that you need. And that's going to differ for each business and probably for each system. And this also extends to renting infrastructure via public cloud. Certainly for all the talk about the elasticity of the cloud, probably nowhere is it more relevant than the big peaks and troughs of data processing. So as far as scalability goes, you should take a forward-looking approach to your data stack. Data sizes will continue to grow. I think that's a inevitable trend. So make sure that your choice of tools can accommodate. A lot of the tools in this space are built on usage, which is great. I think it's absolutely the right model, but make sure that your budget reflects that in terms of the growth, so that you're not tempted later on to have this fixed idea of what you're up for and then trying to maybe architect around the pricing later on. Choose a data warehouse that can scale rapidly and supports high concurrency. I think that second part is really the key to being able to deliver value everywhere outside the traditional data warehouse. You should definitely understand the storage constraints of your cloud apps before you pump data into them, again, so that you don't end up either with quota issues on those platforms or creating these kind of awkward data models to work around those limitations. For any real-time machine learning inference APIs, I think it's really worth having a plan for how they're going to be retrained over time to counter model drift. Consider using something like MLflow. Virtually all examples I've seen of tools in this space end at the deployment of the first version, and not the ongoing reality that they're going to need to keep changing. So at least practice updating those endpoints before you take them live. That's the end of the main part of the talk. And I've got a couple of things to plug before we maybe take some questions from either my friends here on Zoom or from the YouTube audience. I mentioned DBT quite a bit in this talk because I'm fully on that bandwagon. There's another James Peterson, who's going to do a talk on more depth next month. So get yourself along to that. And of course, as promised, my product, time to plug it. If you're using Snowflake and Salesforce, you get a native push mechanism where you simply call a Snowflake function at the end of your pipeline and it gets loaded straight into Salesforce. How good is that? You can manage it as part of your DBT project. In fact, we're working on a DBT package to help manage that. And for a larger data set, I talked about considering live access from your data warehouse. This is exactly that for Salesforce. So you simply create external objects on the Salesforce side, link them to each other, and you'll see Snowflake data fetched in real time. So you can link all that rich customer related data from other systems, sprinkle in your own machine learning magic, and then put it right in front of users. So if you're interested, hit me up on the Slack channel or add me on LinkedIn. Questions and comments?
Well, first of all, a round of applause. You probably can't hear it all because we're all online, but Michelle definitely is clapping. Yeah, it's we usually don't do sales pitches at the data engineering meetup, but I think it's I could probably speak for everyone in saying it's just it's wonderful to see you know, data engineering SaaS companies springing up in the local region. So I think we're all cheering you on, James, and really, you know, proud to, you know, see all the awesome work that you're doing. So good stuff, and hopefully there's more to come, you know, out of the local data engineering scene. So cheers. We do have a couple of questions. I think we've got one from Ravathi in Zoom. So she's asked, hi, James, can you expand more on the storage constraints you've mentioned? With most of the cloud services, we don't have to worry on size. So what is the constraints here?
Yeah, I'm talking about particularly these software as a service platforms, particularly the big multi-tenant ones. So Salesforce is one example of that, but pretty much pick any of them, whether you're on Dynamics or some marketing platform. When you're dealing with data sets in the scale that you have in a cloud data warehouse, replicating into a data warehouse, nobody worries about size because they're just built for that scale. But pushing data back out, it's quite possible that your cloud vendor might not want 10 million records in their system, even if you can do it. So that's what I was talking about in terms of planning for how to build the rest of that pipeline.
Very cool. So Dash D said, question for James. I didn't catch the name of the open source Snowflake tool utility you mentioned earlier that's on GitHub. Can you please reshare?
Yeah, it's currently called snowchange, but it's going to have a name change soon because it's confusing people that think it's an official Snowflake product. So
right.
Just look at Snowflake Labs, which is github.com/snowflake-labs, and it will be fairly obvious there which one it is. So it's
cool.
kind of like a object management tool on top of Snowflake.
Awesome. We've got a few people on Zoom here with us. If you would like to ask James a question directly, feel free to take yourself off mute and put your video on if you like. I'm going to drop that repo into the YouTube chat. Cool. And Loris Marini said, well done, mate. So there you go.
I like comments too. That's good.
Yeah. Perfect. All right. Obviously, James, you're on the data engineering meetup Slack group and things like that. And you're also on LinkedIn and things like that. So I'm sure you'd be more than happy to chat and take questions after the event. I'm very surprised Kurt hasn't popped up and asked a few snarky questions or anything like that. No? No one else? Temptation was there, but
no, look, it was a good presentation, and I tend to agree with a lot of what James said. There's a lot of good insights there, and a lot of well-earned lessons, I think. A lot of experience underpinning it all.
One question that I have, James, in terms of querying Snowflake, because generally speaking, I love databases, and obviously Snowflake is very performant. It's scalable and amazing, but still it takes usually a few seconds to return a result. There's a lot of applications that are totally cool with that sort of latency and stuff like that. But are there patterns that you see for low latency? So you want to do your data crunching in Snowflake, for instance, or whatever warehouse you're using. What sort of patterns can you offer to lower the latency if you do need lower latency?
Yeah, I think while people solve this themselves, the vendors will be solving it at the same time as usual. So there was a tiny slice of one of the Snowflake co-founders talks late last year where they were talking about the future of it, and very much hinted at tackling the low latency challenge. Working with Salesforce is no problem because those queries run faster than a standard screen loads in Salesforce anyway, so nobody even notices. But yeah, if you're in a system where 10 milliseconds is a long time, then you would have to build something like a caching pattern. I would say it depends on if you're talking about like bespoke software that you own, you're probably talking about replicating it out into a really low latency operational data store. And for anything else, then it's going to depend on what that system can talk to. But yeah, I would say that right now, when you're talking hundreds, maybe thousands of users, which usually means internal to a company, for a standard cloud app, that a product like Snowflake is already there. If you're talking about hundreds of thousands or millions of of users concurrently, then I think we'll start to see solutions emerge for those, both, you know, patterns that people build themselves, and also companies like Snowflake will be providing that mechanism.
Yeah, cool. That sounds like an interesting peek into a bit of the product roadmap there for Snowflake. Sorry, so that's really interesting to see. Okay, did you have another question?
I got a comment that I did a Salesforce burn just then in the chat.
Boom.
We're a Salesforce partner. We love Salesforce. That wasn't a burn. It was just a comment about the expectations of those users. But yeah, maybe I can see why it would come across as a burn. But any of those highly configurable apps are not known for, you know, single digit latency of page loads. So I think we all hopefully know that.
Yeah.
Mine was sort of a half-formed question around, you said you love DBT, and I like that it's very approachable, that it's very SQL based, but I'm also a big fan of the ideas of data mesh. That's a ThoughtWorksy thing, no plug or anything, but James and I have had discussions before, but particularly it's very much event source based. So you're emitting business events, which is more enriched version of CDC, and you're bringing your data sources together. So rather than having separate analytical data stores that would be OLAP and separate data stores for application integrations, you're trying to bring these things together as an event stream. dbt feels very scheduled and great for the analytics, I guess. I'm sort of having trouble picturing how we can bring that in to a more near real-time streaming piece.
Yeah, I think there's a natural batch element to using SQL to process that data. I would imagine I've never seen a real data mesh in the wild. I hear they exist, but the various owners of data throughout the company would probably rely on a tool like dbt and an associated pattern if they're going to allow lots of different people to consume data from their subject area, even though the work to do that might not be centralized. I would have thought the platforms would still be. Would you use data mesh to collectively build a warehouse, Kurt?
I'm going to quote Zermatt, the author, as data warehouse being a node. So they're a consumer. They source a lot of data from the distributed mesh, and then they model it and present it for, I guess, more highly curated use cases. I think regulated entity reports, like maybe ASX listed companies, etc.
Very good. I think perhaps we'll have to get Kurt eventually to come and present his thoughts on data mesh, and we could probably have a special guest appearance from James to return the heckling favor.
True, sounds good.
But
please,
yeah, awesome.
I think
next
I was just going to throw in the last word that data mesh sounds a little bit like communism to me. Really good in theory. But I'd love to see one where everyone's happily participating.
Cuba?
It sounded really cynical, but I think
no, look, I hope to provide that example to you, and I think I'd like to hold off until I can at least plausibly respond to heckling.
Good.
Thank you.
Oh yeah, some great debate in the works, I'm sure. So that's really cool. So up next we've got Michelle Playfair from Yale Conferences. She's going to tell us a little bit about what's in store at Yale Data this year.
Awesome. Thanks very much, Peter. Hello, friends. It's nice to see you all once again back here. I am going to attempt drum roll, please. I like a good experiment. I'm going to attempt presenting from Canva. Canva, fine Aussie product. Good supporter of both Yao and the data engineering community here in Australia. So can you see my screen? Is the question. Yes, thumbs up. Awesome. So thanks so much, Peter, for the shameless plug. Yao, if you are unaware, is a conference company based in Australia. We've been here for 10 plus years. I think we're up to 12 years now. And the recent excitement over the Christmas period, Merry Christmas to us, was we have joined up with a company called Skills Matter. So if you've ever been in the UK, you might have heard of them. They are absolutely massive. In the UK, they have more than 100,000 community members from 126 countries. They run a shed load of events. They've had more than 4,000 events, both meetups and conferences. They run a lot of training courses. I should say we now run a lot of training courses. And of course, now everything is online, which is even better because we have access to the fire hose of content, which you can get from Skills Matter. So yeah, go to the website, check it out. There's a truckload of stuff there. So let's see, what does this button do? Oh, look at that. Over to Yao Data or Yao Data, depending on your regional pronunciation, which is going to be online on May the 13th, which is a Thursday. We're really hoping that we will be able to have some kind of an in-person aspect to it, which might be afterwards at a sort of reception-y type thing across multiple cities. So we're working on how we can do that safely and carefully, of course. So it's going to be one day and we're going to run 3 tracks. So if you joined us last year for our first very experimental online experience, we spread it out across 3 days, but we'd like everybody to be able to get together at the end. So we're going to try, for this year's experiment, 3 tracks. So obviously data engineering is probably of most interest to folks here, but we'll also be running data science and machine learning / AI track. So what we'd like to get from you all is, what would you like to see? Who would you like to see? What would you like us to try and bring to you that will make it so that you think this is something I really must attend? Normally we do a CFP, which we're not doing this year because time, but on the upside, it means we can access speakers from everywhere, being that we are online. So I am in the Meetup Slack. I will post something in there so you can find me, and please hit me up with all of your ideas for speakers and topics, and we would love to give you what you would like to see. We are going to open up diversity and student scholarships soon. So if you are a student or somebody who doesn't normally get to attend conferences, there'll be a way for you to attend that for freezies. So stay tuned for that. We also have another way to get there, which is Yao Online membership. So if you join up for a year for $275, you get to attend Yao Data and any other online thing for free, which is also now including all the Skills Matter stuff. So it's a heck of a deal. And you can find out more information at the website there, yaoconference.net/home, which will tell you all the goodies you can get. And you can join monthly, but I recommend the annual one. So check that out as well. And is my GIF's not working? Oh, sad face. It was so pretty. Never mind. See, experiment fail. Just picture, if you will, a fabulous animated GIF. So there is an event coming up from Skills Matter called Accelerated Software Exchange Forum, which just trips neatly off the tongue. And a lot of that kind of ties into what the talk was about just now. So Dave Farley, who you've probably heard of, he's one of the OGs of DevOps, and he's one of the speakers. So is Heidi Waterhouse, Barry O'Reilly, and now also Chelsea Troy. It's all about how to deliver software faster. So they're going to be talking about DevOps, refactoring, releasing, lean enterprise. The bad news is it's the middle of the damn night for us. So there will be videos, but this is kind of an example of one of the events that you'll have access to as a member for nothing. And you can find out more about that on the Skills Matter website, and we'll be promoting it as well. So hopefully, yeah, there's going to be some stuff that you're interested in, and just reach out on the Slack. And yeah, that's it. Thanks, Peter.
Awesome stuff, Michelle. Always great to hear all the great content coming out of I've always been a massive supporter, and I think and also have been huge supporters of the data engineering meetup. So we're always ever so grateful, to you and the team, for all that you do. So thanks so much. Definitely looking forward to getting along to Data this year. I think based on today's discussion, perhaps data mesh is a good theme to chat about if you've can rustle up a few speakers on that. Cool. Awesome. Well,
I think Kurt volunteered, didn't he? Isn't that what I heard earlier?
Exactly, yes.
Well, I've written your name down, Kurt, so yep.
Thrown him under the bus. Woohoo! Joking. Cool. I'm going to dive straight into the reInvent recap. Obviously, I'm not officially, I'm not an AWS employee. I'm a AWS serverless hero. So always read the FAQs on the actual pages, when considering any of these services. And obviously there's a huge vendor ecosystem in the data engineering space. So AWS is part of that, but they're not the only option. So, have a look at what works well for you, but definitely find that, there's some really good innovation happening in AWS. So definitely worth taking a look. So without further ado, I'll just dive straight in. So I think the biggest news probably coming out of reInvent, or was it pre-invent, for this one was managed airflow. And it just takes away the hassle of rolling out Airflow yourself with having to, spin up a RDS instance and, handling all of the queues and all of these sorts of things. So it offers you, a very scalable product. There's all of the inbuilt security around the IAM ecosystem. Obviously, the cost, I think it's around the $500 a month mark to get you started. So that's, quite attractive. And then there's also a plugin ecosystem where you can sort of run your jobs on EMR, Fargate, and EKS and the like. So that's quite a compelling story. Be interested to hear in the chat if any of you have deployed that here in Sydney just yet. On the Redshift side of things, there's the new RA3 XL Plus instances. So these new RA3 instances are probably a little bit like some of the other cloud data warehouse vendors where they separate storage and compute. They were announced at last reInvent. This reInvent, they've announced this new instance size, which is probably at a better price point for, I guess, small to medium businesses, whereas perhaps the other ones were a little bit more on the enterprise price point. So that's really interesting to see. And they've also come out with this auto table optimization. So, you don't need to really worry about, distribution keys and that sort of jazz anymore. With your existing tables, you can update those existing tables to leverage this auto table optimization feature. So that's really cool to note as well. Aqua for Redshift is bringing compute down to the storage layer. So that's a fascinating innovation that perhaps some of the vendors might have trouble sort of competing against, because it's kind of leveraging, I guess, the at the hardware layer or the virtualization layer that AWS have. Another Redshift preview is native JSON support, and then there's federated queries for RDS and Aurora MySQL. And I think that's a big feature of what reInvent provided this year, where if you're stuck or if you're sort of contained within one particular product within AWS, that a lot more of the services are coming to you within that particular product. So if your day-to-day life is spent within Redshift, then you can sort of stay within Redshift and go out and query RDS or Aurora MySQL and bring that data in without having to leave the comfort of your own cluster or something like that. Cool. So this, and on that point, Redshift ML has come out. So that allows you to run machine learning jobs using SQL. So and sort of call in sort of SageMaker instance jobs. There's data sharing capabilities where you can share data with third parties, a capability that other data warehouses offer. And then there's also a partner integration in the console that's in preview now. So I think that allows you to bring in things like Google Analytics data and the like. So that's an interesting one. If anyone's, I haven't actually had a chance to play around with a lot of these features, but if anyone's had a bit of a play around with them, I'd be really keen to hear what you think. Cool. On the Glue side of town, Databricks is a really cool announcement. I think that was from pre-invent as well. So I don't know if any of you folks have used SAS back in the day where you could sort of auto-analyze like a CSV or a table, but what Glue Databricks allows you to do is just basically, you know, give you some summary statistics on a file and kind of, you know, you can tell, you know, how many unique records there are in a particular column or something like that, and give you a bit of a feel for a data set before you sort of start hacking away. So I think that's a really cool service. And I think there's a new step functions integration so that you could probably dump a file into S3, kick off this step function job, and it'll come back and tell you when it's done, sort of analyzing that. So that's really cool. Glue's got its very own schema registry, so I think that's going to have a lot of applicability with folks that are using MSK and the like. So that's going to be able to you know, keep track of all of the various schemas of your events and things. And then Glue Elastic Views. I think this is actually going to be huge. So think that, say, if you're using, you know, application databases like DynamoDB, for instance, you're going to be able to use SQL to create a materialized view of that data in DynamoDB and materialize that in places like S3, Redshift, Elasticsearch, you know, bringing in different data sets together as well. So that's probably going to take away quite a fair bit of data engineering heavy lifting, which is really awesome to see. Lake formations. So on this, there's now Lake Formations offering transaction support and I think row level security. So and acceleration. So that's really cool. And then also AWS have announced this new Health Lake data lake. So I think that's going to be leveraging the, you know, Fire API set of APIs and standards. So I think that's just going to help those folks working in health-related industries rapidly sort of leverage data lake capabilities and the ability to sort their health data into appropriate domains. I'm sure there's a few people on the call that could talk to that a bit more. On the EMR front, Elastic MapReduce, if you're not familiar with that, they've got EMR Studio, which is basically Jupyter notebooks that have got a rich feature set that they come along with, and you can use SSO or your corporate credentials to log into them and share them between users. So that just allows you a nice, easier way to interact with your EMR cluster. You can now run EMR on EKS. So if you've got, Spark jobs or something like that you want to run there, that's totally possible now, and it brings with it the rich feature set that EMR offers. And then Graviton 2 instances, they're that new ARM chipset that just allows for much improved performance. So if you switch your EMR clusters over to that, I'm sure you're going to get some nice performance improvements. Other things to take note of from reInvent is Neptune. Neptune is AWS's managed graph database, and now they've released Neptune ML. So if you're using, say, Gremlin to interact with Neptune as your query language, you can also run machine learning queries from that, hitting SageMaker notebooks and the like. AppFlow is a little bit like Fivetran in that it can stream data from, say, Salesforce to, S3, Redshift and the like. Lots of SaaS applications like Marketo and things like that. AppFlow have announced that they've got Lookout for Metrics. I actually think Lookout for Metrics is going to be quite a fascinating tool for data engineering when it comes to actually seeing when, there's outages and breaks and things like that in your data engineering pipelines. It's usually using machine learning models to ascertain whether things have, broken or, things have fallen off a cliff all of a sudden due to perhaps a schema change or something like that. So I think Lookout for Metrics integration will be really cool, and a cool development to see where AWS takes that pattern in the future as well. And then on AWS Batch, if you haven't heard of AWS Batch and you're like, what the heck is it? It seems like it's an EC2 instance with an auto-scaling group. It's kind of one of those services where you kind of have a workload or lots of workloads that don't need a lot of user interaction. You just kind of set and forget and let it compute it all over. That's basically what AWS Batch is, and now it's got Fargate support, so you don't need to worry about EC2 images and things like that. So that is really cool to see as well. Less management overhead. So that's pretty much all I had to talk about in terms of reInvent announcements. So yeah, any questions or comments on what you've played with, or what you think about all of those announcements? Let's have a look.
I'm not sure anyone wants to hear from me, but I know Quinnypig, if you don't follow him on Twitter, quite funny, sarcastic commentator on public clouds in general. Has a theory that Route 53 makes the most cost-efficient database, but the interesting part about those announcements is S3 is a pretty solid second place to Route 53, and things like consistent read after write, I think, has been a big reason to not use it for a lot of data capabilities and uses. But adding that in for free effectively must have been an amazing engineering effort in the back end. Like the stuff these hyperscale people like Azure or Google, Amazon do, it's just quite mind-boggling.
Yeah, exactly. That's actually one announcement that I failed to mention in my wrap up, but that is absolutely huge, and it's kind of it does open up the possibility of using S3 as a database, doesn't it? Which is really cool. Yes. Awesome. Well, that's pretty much it. Do reach out. We're going to have another meetup in about a month's time. We've got the DBT meetup coming up in mid-February as well. So yeah, just feel free to reach out and just let us know if you're interested in presenting, or you'd like to see some presentations of a certain ilk, and then yeah, get yourself a ticket to Yao Data as well, and perhaps you know, reach out to James if you're interested in what Omnata has to offer. So anyway, thanks everyone. Ciao for now, and a big shout out to Michelle Playfair and James Weakley for joining us today, and see you all next month. Bye.